So we've discussed measures of center like the mean and the median, but that's not enough to completely describe our data. We can have data sets that have both the same mean and median, but still be very different. So we want to look for ways where we can find other ways to describe data sets. And we're going to start that by looking at quartiles. So quartiles break our data into 4 pieces, hence the quartile. However, there are only 3 quartiles because it breaks the data into 4 different pieces. We denote these 3 numbers by Q1, Q2, and Q3. So when we say it breaks our data into 4 pieces, we have things that are less than Q1, things between Q1 and Q2, things between Q2 and Q3, and things bigger than Q3. And quartiles break it up evenly so that there's 25% in each one of these little portions. So let's look at actually finding them. We start with finding Q2. Q2 is going to be the easiest to find because Q2 is just the median. Q2 has 50% of the data above and 50% below, which is the exact same thing as just the median. Once we have the median, that breaks our data up into 2 pieces. Like I said, 50% below and 50% above. Q1 is then the median of this lower half of data. Everything below the median, we want to find the median of that. That would be Q1. Q3 would then be the median of the upper half, the median of everything above the median. So let's look at some examples on how to find this. Here are 10 numbers that are scores on an exam for a statistics test. We want to find our quartiles, Q1, Q2, and Q3. So we start with Q2. Q2 is just the median. We can check here, and there are 10 data points. So the median would have 5 to the left and 5 to the right. Halfway between 78 and 82, which would be 80. Next, we want to find Q1. To do this, I need to find the median of everything to the left of that vertical line that I drew. The median of everything to the left of the median, which in this case would be 68. So Q1 is 68. Finally, we want to find Q3. For Q3, we need to find the median of everything to the right of this line, which would be 91. So I have my 3 quartiles, 68, 80, and 91. Let's look at another example. We're going to start by finding Q2. Here there are 9 numbers, so we can actually find a direct median that has 4 to the left and 4 to the right. Therefore, Q2 would be 15. To find Q1, we then need to find the median of everything to the left of this box, and we don't actually include the box. So for Q1, we need to find a number halfway between 10 and 10, which would be 10. Finally, we're going to find Q3, which is the median of everything to the right of this box. In this case, halfway between 20 and 30, which would be 25. So now I have my quartiles. We'll now extend the idea of quartiles into what's called the 5-number summary. The quartiles were 3 different numbers, so we're going to add 2 things to the quartiles to get the full 5-number summary. So the 5-number summary consists of the minimum value, so the smallest value in the data set, Q1, the median or Q2, Q3, and the maximum. So we're adding in 2 values, the minimum and the maximum. So let's go back and look at our examples and see if we can get the full 5-number summary for them. Here was our first example where we found Q1 to be 68, Q2 to be 80, and Q3 to be 91. So we're missing 2 numbers for our summary, the minimum and the maximum. We can look at this data set and see that the minimum is 42 and the maximum is 97. So now we have the full 5-number summary for this data set. Now let's go back to this one. We had Q1 to be 10, Q2 to be 15, and Q3 to be 25. So we need to add the minimum and the maximum. We can see from this data set that the minimum is 5 and the maximum is 45. So now we have the full 5-number summary.